Hey, AP Computer Science, we're going to talk now about the rock, paper, scissors assignment. This is review assignment number 2, and I just wanted to go over my solution for it. Again, if you got it to print out exactly as the assignment, then you're doing fine, however you did it. And there is a certain amount of art to it where there's no, perfect or right answer. Sometimes it's individual to yourself and to your team if you're working with a team of people. So here's my answer, and I hope that's useful to you. So first of all, we're having our class called RPS. Could have been review assignment 2, whatever you want. And then I'm using global variables for most of my stuff so that my various methods can access them. It's not necessarily the best way to program. Global variables are potentially error prone, and in a small scale project like this, it's no big deal, but we'll be learning about more advanced techniques down the road. But for now, I think this is a good time to use some global variables to keep the problem fairly simple. So we have a scanner. We have some final variables for the words rock, paper, and scissors so that we can use ints to represent them, but still program with words rock, paper, and scissors. It'll get really confusing if we don't use some kind of word because we're like, 1 beats 3 but loses to 2. Doesn't, make as much sense as rock beats scissors but loses to paper. Although I guess that doesn't actually completely make sense either. But we're used to those conventions. Whereas 1 beats 3 but not 2 doesn't really, nobody feels good about that. I have some variables to keep track of wins, losses, and ties, and then these are for generating the human choice versus the computer choice. There's actually no reason for them to be here. I don't know. I just put them up there. We could have put them anywhere. So remember that where the variables are defined, that's going to be their scope. So I used to have some of them in here, but I've moved them. Don't have any variables down here anymore. So if they're declared here, their scope is everywhere from the beginning, or everywhere in the class. Basically, we just look for that previous brace, and everywhere until that close brace, that's where they're usable. So this is my main method, and I think this is a good way to program. If you were to show someone your main method, it should represent um, for more complex, larger programs like this, which isn't super long, but it can represent sort of a outline or summary. And you can use it for your own purposes as an outline or summary. So I've just sort of broken it down into the different steps. Like we're going to print the intro, we're going to have a while loop, or we're going to keep on doing this sort of repetition of the player throws a symbol, the computer throws a symbol, we print out the choices and we see who's the winner. And then we keep on doing that as long as we want to play again. At the end, after the while loop is done, presumably the person doesn't want to play again, then we print out the stats and see how that turned out. So that's basically like a recipe for how you do rock paper scissors, right? And that's also an outline for things to do, right? So I'm like, okay, well now I have to go do this, I have to go do that. You can kind of check this off and break a larger problem into several smaller problems. That's a super, super useful thing to do in computer science, so that you're not trying to do everything at once. So I'll just go through each of these methods one at a time to show you what they look like. Most of them are pretty simple, so I'll try to highlight the important ones. So first of all, print intro. It's just some printing. I don't know what the X is doing there. Clean that out. Who needs an X? No X needed. So there's something to delete. Basically, it just prints out the good luck human stuff. And then our loop begins, so we get the human choice. And if we take a look at that, it's basically, just us saying, here's our choice, and then we're getting the choice. I'm not doing any kind of error checking here because, we're trying to keep this as a small scale problem, but I could imagine, you forcing the person to press 1, 2, or 3 would be a pretty good innovation on this project. But that's all we need to do. This variable, of course, is declared as a global variable, so I don't need to sort of send it back with return or anything like that. And then we got the computer choice. So that's going to be the next one. This is where I just generate the random number. And it's going to be important for you to know how to generate random integers. That's something that's on the AP exam and also possibly on the unit test coming up. You've noticed we've done this quite a bit, hey? D6, how many times have we rolled dice in the assignments? This is just a thing to know how to do on the AP exam, so we kind of build that into our questions. So there it is, our casting our int. Don't forget these parens because of bed mass and the casting operators coming, highest precedence. So that's what's going on there. So we generate the computer choice, and then the next thing is we print the choices and then calculate the winner. So we'll take a look at that. So printing the choices is just kind of a big old if-else if chain. So we just print rock, paper, or scissors, depending on whether the human chose this, that, or the other. Same with the computer. I could see a nicer, cleaner method where we maybe can, like, there's a lot of repetition going on here. I feel like, the I and the U could be, somehow condensed, and then the through rock and through paper could be fixed a little bit. So, actually, I would almost go and do that with a parameter and change that up. You could send I'm not sure what the term for that word is, a U or an I, the identifier. I'm not sure. In English, there's a proper word for that. We could send that as a parameter. It would be a nice improvement. We could divide this in half, really, and call it twice. We could print choices twice, and yeah, we could save ourselves some lines of code. This is a simple, fine way to do it, though, and maybe it's good to keep it simple just for the answer key. But there's a nice improvement that you can make for your code to condense it a bit more. And then I guess we have to evaluate the choices. So basically, I just have a really long if statement here that goes, I don't know, for quite a while. Here's all the possible conditions under which, the human can win and the computer can lose. It's pretty easy to see if it's a tie. If the two things are the same, it's just a tie. And of course, if any other condition happened, then, the computer, I guess the computer won. If it wasn't a tie and the human didn't win, must have been the computer. And I'm just increasing the number of wins and ties and losses as we sort of do this if-else if statement. And then this is probably the most interesting method in here is the want to play again method. So notice that it's inside of a while loop. So that means that it is returning a value. It must be returning a value. It's not a void method. It must be a Boolean method because while loops want Boolean expressions. So if that is going to be the only thing inside the while loop, it must be returning a Boolean. So it just looks like this. Here it is. So notice it's public static Boolean, Boolean being the key thing there. So it basically just reads in the answer, and then we return whether or not the answer equals y or whether it equals, well, I guess capital Y or lowercase y. So if it equals either of these things, that expression evaluates to true, and then it returns true. And if neither of them is true, it returns false. So that way we can kind of wrap that in a method and keep our outline here nice and tight and condensed. At the end, we print the stats, so it's pretty simple print line type of thing. Print good game, and it prints out the wins, losses, and ties. So that's how I structured it. So there's definitely some room for improvement in this code. I don't think it's flawless by any means. So as an exercise, you can go and implement some of those changes, or you could think about how to tighten it up even more. Obviously, time is not, you don't have infinite time lying around, so probably better to go and do practice or review assignment number 3 before you play with that. But I could see that being an interesting exercise to try to tighten it up as much as you can. Anyways, there's the answer to that question. I hope it was a fun project, and we'll talk to you later. Bye, everybody.